So one root is 4 minus I, the other root is 4 plus I, right? And if we have one root that is 3 plus I, the other root would be 3 minus I. So we talked about that already. We're going to, the domain and range questions, we did the first one together, I believe, but I'll do that again. Just as a refresher, the first thing you want to do, since this is in vertex form, and they're asking you to find the domain and range, you want to find the vertex. So the vertex would be the opposite of what's in the parentheses, so that's going to be a -3 and a 2. Since the vertex is 3, 2, I can draw a little sketch if I want to. And -3, 2, like I said. And we want to pay attention to whether it opens up or down. It opens down since there's a negative there. The domain for a parabola is always the same thing. What is it? It's all real numbers. Good. So the domain here is all real numbers. The range is based on the y value of the vertex. So less than, or all y values would be less than or equal to 2. Number 28, the vertex here is 5, 4, opening, it's a +2, so it's opening up. So 5, 4, opening up. Domain is, again, all real numbers. Range is all y values greater than or equal to 4. Y is greater than or equal to 4. Number 20, vertex is +12, -6. So +12, -6, here's my point. Opening, there's a negative sign there, so opening down. So I know that this is a maximum, so my range will be y is everything, all the y values are less than or equal to -6. And again, the domain is all real numbers. Questions on domain and range questions? Bailey.
The only thing I'm always getting mixed up is like the range whenever you have to put like the less than or greater than. That's what I get mixed up on, is like remembering which one's which. How should I do that?
So if it opens up, all the y values would be above or equal to.
Okay. Okay.
So opening up means there's a positive value in front.
I knew that. It's just like whenever you write the sideways carrot, whatever you want to call it.
So then transformations happen. We talked on number 30 about comparing these two graphs. The first graph happens to be our parent function parabola at the origin. The second graph has a vertex at, put a +0 there, it helps maybe identify that vertex as +3, 0. So my new graph is here, and that demonstrates a transformation of translating 3 units right. For number 30. 31, again, we have the parent function parabola at the origin. The vertex of our second parabola is 6, 7. So from the origin to 6, 7, it's pretty sketches. We would have a shift, a translation of 6 units right, 7 units up. So I got confused with 3. So 6 units right, 7 units up. The last one is key, because notice it doesn't start at the origin. It starts at a vertex of +8, 0. And the next one has a vertex of -8, 0. So if we start at 8, 0, bump to -8, 0, how many units have we translated and in what direction? Left. 16 units left. Say that again. You could if you only saw the graph. But because we have these two equations, what actually happened here was a shift of 16 units left. But great question, I like that. Or great alternative based on the graphs. 33, write the formula for the discriminant. We just talked about that, so that's b squared minus 4ac. The purpose of that formula is to help us determine how many solutions we have. If the value is positive, we know that we have 2 solutions. If the value is negative, we have no real solution. Sometimes we say too complex. And if it has 0, we know that we have 1 solution.
What?
Baby.